Hi everyone. So yesterday we talked about the quadratic formula, and the quadratic formula is how you find the solutions to a quadratic equation. And we're going to kind of expand on that today and talk about what those solutions really represent. And we're also going to talk about the different situations you might find yourself in terms of those solutions. So what I want you thinking in this lesson, and maybe just make a note on this first page so you recognize it later. We're going to be using something today called the discriminant. And we'll talk about what that is in just a minute, but I wanted you to have that right on the very front page so you can be thinking that word all the way through. And so later when you're looking for it in your notes, you know this is the lesson where you're going to find it. Hopefully I spelled that right. I can't talk and spell at the same time. Discriminant. Yep. Okay, so nature of the roots uses something called the discriminant, which is actually a piece of the quadratic formula. Okay, so when we graph a quadratic equation, we get this shape called a parabola. We've been talking about parabolas a lot. And the points we're looking at today are these points here. Here and here. Actually, I should probably choose a different color. Huh? Let's find something that's going to pop out a little bit more. Maybe this. Here and here. And those points there are what's known as the roots of the quadratic equation. So we spent a long time talking about the vertex. I want to make sure you're not going to get mixed up here. This down here is the vertex, but these points are special for their own reasons. And so these are called the roots. Now those should look familiar to you because we've been doing graphing all year and we've talked about these points before. Notice the roots are the place where this parabola crosses the x-axis. So if it's the place where it crosses the x-axis, we could also call them x-intercepts. Okay, so roots is just a fancy name for the x-intercepts of one of these graphs. They're also called zeros, and you'll see in a minute why they're called zeros. I don't know why we have to have so many different names for the same thing, but if I ask you to find me the roots, or find me the x-intercepts, or find me the zeros, or find me the solutions, I'm going to throw that one in there too. We talked about solutions yesterday. Solutions are more if I just give you an equation and not a graph. But all of these things are found the same way. The roots, the x-intercepts, zeros, solutions, that's all talking about these points here. Well, if we're talking about an x-intercept, I want you to think way back to chapter 3 when we were graphing these things. And I was telling you to find me the x-intercept. What do you always know at the x-intercept? There's your favorite question back again. Remember I asked you that a lot of times? What do you always know at the x-intercept? At the x-intercept, you always know y is equal to 0. So to find the roots or to find the solutions to one of these quadratic equations, you are just going to set y equal to 0 and then solve. Okay, so to find So anytime I ask you to find the roots, if I hand you an equation and I say find the roots, you're going to take that y value, make it a 0. Whoops. Take the y value, make it a 0. And then, remember yesterday when we talked about the quadratic formula, I told you that you always had to have it equal to 0. It's going to be in the exact form that you need it to be in to do the quadratic formula. And that's how you solve one of these. So when I say solve, I'm talking quadratic formula. So see, it's all connected. So there's 3 different situations you can be in with one of these parabolas if you're looking at the graph. Probably what you're the most used to and what we were just looking at on the previous page is a parabola that swoops down like this. And you'll notice this parabola crosses the x-axis twice. So this one we would say has 2 real roots. The real is going to be important later. You might think it's silly to have to write that they're real, but we're going to talk later on and into the next semester about what it means when they're not real. Then you can have these parabolas that are just barely perched up there on the x-axis. So they're just sitting on the x-axis. Their vertex is right on the x-axis. It's not dipped below like this one. And then you only have one x-intercept. You only have the graph hitting one time. So this one we would say has one real root. Okay, so if it's sitting right on the axis, it only has one root. And then you have the floaters. The floating parabolas are the ones that don't dip past the x-axis at all. You could also have them down here like this, where they don't get up high enough to hit the x-axis. This one has no x-intercepts. It never hits the x-axis down here. So this one we would say has 0 real roots, or no real roots. So every quadratic equation I ever give you is going to be one of these three scenarios. Either you're going to have 2 real roots, which is what you were dealing with yesterday too. Do you remember most of the equations you solved came out with 2 answers? Okay, that's your 2 real roots. It is possible to have exactly one answer, and it's also possible to have no answers. This would be the problems from yesterday where you got no solution. And I know there was one in our notes. I'm not sure if there were any on the homework or not, but if you're solving and you get no solution, this is what you're dealing with. You're dealing with a floating parabola. It never crosses the x-axis, and so you're looking for something that doesn't exist. So here's how you can figure out which one of those 3 scenarios you're dealing with before you even start to solve. Here's your friend the quadratic formula. This is what we were talking about yesterday. If you look at just this, just what's underneath the square root symbol, not including the square root symbol, the b squared minus 4ac is what's known as the discriminant. And what the discriminant does for you is helps you tell the difference between the different situations, like we were just talking about. Helps you tell the difference between having 2 solutions, 1 solution, and no solutions. Okay? And here's how it does that. This is something we've been talking about for a long time now. I'm taking the square root of whatever that's equal to. So if this number down here is positive, if when I do b squared minus 4ac and that comes out positive, and then I take a square root, aren't I going to have 2 answers? All right, we've been talking about that since way back at the beginning of this chapter, that positive numbers have 2 square roots. So this here says if d, that's the discriminant, so I'm going to draw this and then probably erase it so it's not confusing. D is referring to the discriminant, which is this b squared minus 4ac. If it's greater than 0, which is another way of saying positive, then you're going to have 2 roots. I guess I should say 2 real roots, but I made you write that on the previous slide. So anytime this value, the b squared minus 4ac, comes out to be positive, I'm going to have 2 answers. If the b squared minus 4ac comes out to be exactly 0, think about what happens when you take the square root of 0. Remember I told you that that's like your one exception, your one weird one? Square root of 0 is just 0. There's no positive, negative. You're not going to have 2 different answers. So if that discriminant comes out to be exactly 0, that's when you're going to have 1 root. Because the square root of 0 only has 1 answer. And if the discriminant comes out to be less than 0, which again is another way of saying negative, if the discriminant comes out to be negative, well, if the discriminant comes out to be negative, then you're taking a square root of a negative number. Not possible. So that's when you would have 0 roots. So a lot of the questions you're going to hit in this section are just handing you equations. And they may word the question differently, but really what they're asking is which one of these applies. Okay, does this equation have 2 roots, 1 root, or no roots? And what the discriminant is supposed to do for you is save you the work of doing the entire quadratic formula. It's saying if you just figure out this piece of it, you can decide which one of these you're dealing with. Now, if the question asks you what are the actual roots, then yeah, you're going to have to go back and do the rest of this. But if it just says how many roots would it have or how many solutions would it have, you can stop right there. So let's try one. So it says find the nature of the roots. And I worded it that way because a lot of the worksheets word it that way, but really all that's asking is how many roots does this equation have, and are they real or not real? And right now we're only talking about real roots. We haven't talked about non-real roots. So that's easy. So first step, I need to set this so that it's in my form that I can use the quadratic formula. And it's pretty close. This is in standard form. I just need this to be a 0. Okay? So I'm going to say 0 equals 6x squared minus 3x minus 4. Okay. If that weren't in standard form, if I needed to simplify anything in here, I would. But this one was already set up for me. Okay, just like yesterday, let's find A, B, and C. So my A would have to be 6. You guys are probably pretty good at this by now. B is negative 3. And C is negative 4. So the first thing I'm going to do is evaluate just the discriminant. And remember, the discriminant is just this piece of the quadratic formula. So I'm not doing the whole quadratic formula, I'm just doing this piece. So to find my discriminant, I'm going to do b squared, putting it in parentheses because it's negative, minus 4 times 6 times negative 4. So I'm just evaluating that piece of it. Give me a minute because I'm going to have to calculate it. 9 minus... comes out to be 105. Now at this point in time, I don't really care about that 105. That doesn't mean anything to me. It doesn't mean there are 105 roots. The only thing I care about is that this came out to be a positive number. Okay, so this came out positive. And if it's positive, that means I'm going to have 2 roots. So that means when I solve it with the quadratic formula, I better come out with 2 answers. Now a lot of your questions, that's where you would stop, because they'll just say, find the nature of the roots, or find how many roots this equation has. And if that's all it asked, that's your answer right there. This particular question tells you, go ahead and find the roots when you're done. So if you have to go back and actually find the roots, you are going to have to use the rest of the quadratic formula. But a lot of the work has been done for you here, and I'll show you what I mean by that. So I'm going to go ahead and solve with the quadratic formula. Again, just to remind ourselves, here's A, here's B, here's C. So negative B, let's see, my B is already negative. It's negative 3, so I'm going to put in a positive 3. Plus or minus the square root of, and this is where life is a little easier now, because we already figured this out. We already figured out that b squared minus 4ac was 105. So I can just put in the 105. I don't have to recalculate that. Over 2 times my a value, which is 6. Okay? Remember, because I'm having to do this plus or minus thing, I have to split. And this is where my 2 answers are going to come from. We just figured out a second ago that we were going to have 2 answers. So square root of 105 is 10.25. So I'm going to have 3 plus 10.25. And that will be over 2 times 6, which is 12. And then 3 minus 10.25, also over 12. Slide this over a little bit. I'm going to go ahead and plug this whole thing into my calculator at one time. But of course, when I do that, I'm going to remember that I need parentheses around the top. Okay. So 3 plus 10.25 divided by 12. I should have my document camera here, or I would show you how I'm typing this in, but I ended up with 1.10, and I'm having to round these. They are big messy decimals. Next one, 3 minus 10.25. Whoops, almost forgot my parentheses. Not taking my own advice. I get negative 0.60. There we go. So my 2 roots are here and here. And that's what I figured out a second ago, was because that discriminant was positive, I was going to have two answers. That means if I were trying to graph this parabola, let's see what I could do. I know it's going to be facing upwards because my A value is positive. Remember that from a few lessons back? I know it's going to cross at, about 1.1, I'm just estimating here, and negative 0.6, so it's going to cross like there and there. I know it's going to point upwards, so, pretend I went right through that point. My parabola is going to look something like this. Okay, so that's what these numbers are telling you. These numbers are telling you, where does my graph actually cross the axis. Okay, that's really it. So it's not very different from what we were doing yesterday. Really, the newest thing is just that discriminant piece, getting this number by itself, and then determining the direction that you're going to go in from there, what that tells you about your parabola. Okay? Homework tonight, Lesson Master 610B.